Everyone, good evening. And today I would like to introduce Dr. Nourredine Djebbar. He is working at the Department of Mechanical Engineering in University of Belhadj, city Ain Temouchent.
Yes.
Is it correct? Algeria?
It's
Yes?
correct. You are correct.
Okay, thank you very much. And the title of today's presentation is Three-Dimensional Finite Element Analysis of the Influence of Varying Mass on the Stress Distribution at the Bone-Implant Interface. Dear Nourredine, please, you can start.
Thanks, everybody. Good evening. The title of the paper is Three-Dimensional Finite Element Analysis of the Influence of Varying Mass on the Stress Distribution at the Bone-Implant Interface. The objective of this investigation is to compare the difference in bone mass stress materials of the crown and to protect the tissues surrounding the implant. The contact problems between two solid bodies, crown, impactor, without friction, and that of biomaterial bone implants. For the design, a contact was simulated between the lateral surface of the crown and the impactor. The results also revealed only relatively the level of stress were transferred from the implant to the surrounding cortical and cancellous bone, with the majority of the stresses transferred to the cortical bone. Maximum varyingmass generated by spherical impactor are lower than the conical impactor. The stresses were transferred from the implant to the surrounding cortical and cancellous bone. Children can close their teeth from the falls or during play or sport activities, especially contact sports such as football, rugby, basketball, and shaking. A crown made of ceramic may be completely knocked out by violent accident as a real tooth. After an accident, the crown may become cracked, chipped, or damaged. The study of the dynamic impact of solid bodies with the crown surface has been of a particular importance to dental prosthesis designers. However, the study of dental prosthesis submitted to the impact is not present in literature in order to evaluate the biomechanical response of dental prosthesis after impact. In this study, finite element analysis is becoming a common method in implant dentistry that allows engineering scientists to study jawbone and implant mechanical behavior and bone-implant interface, as well as to understand how to improve dental implant design in order to function within physiological acceptable limits. Model developed has been used to predict stress distribution and level in bone surrounding implants, which are influenced by both the implant dimension and the biomechanical bond formed between the bone and the implant. Several parameters are highlighted, such as the mass and the shape of the impactor, to analyze numerically the magnitude and distribution of stress in the tissues surrounding the implants and different compounds of dental prosthesis. In addition, to verify the stress distribution in different parts of the dental system when it's subjected to mechanical shock. Several factors such as the projectile shape and its mass have been highlighted. Dental implant and projectile. Dental implant and projectile. The size of the compounds of the prosthesis. Geometrical model, mandibular bone. Mandibular bone. Donc, interaction between the bone and during simulation of the implantation process is complex and requires definitions of contact conditions. In the present study, contact is defined in Abacus software using surface-to-surface discretization because it provides stress that is more accurate and pressure results than no-to-surface discretization. Properties of material. Properties of material. This table represents the properties of material.
Dear Nourredine, I'm sorry that interrupt you. Please, are we on the right slide? If you need to change slide, just tell me please next slide and I will change the slides. Okay? Please tell me if you need to change the slides and I will change them. So are we at the correct slide? So now we at slide which is called model in contact. Yeah?
Yeah, yes.
Okay.
Modeling contact, interaction between the bone and implant during simulation of the implantation process is complex and requires definition of contact conditions. In the present study, contact is defined in Abacus software using surface-to-surface discretization because it provides stress that is more accurate and pressure results than no-to-surface discretization. Abacus enforces conditional stress on each surface. This figure 3 represents assembly of the compounds of the dental prosthesis and crown projectile contact. Properties of material. Properties of material. This table represents mechanical properties of different parts used in the dental prosthesis. All applied material are assumed to be isotropic, homogeneous, and linearly elastic. This table regroups the mechanical and physical characteristics of different parts. Boundary condition. Boundary condition. Bon. Non-linear friction contact with 0.3 coefficient of friction were also used to simulate the contact between abutment implant as well as between implant bone. All other contacts were considered to be of perfect contact. The model were simulated in two steps. The first step was application on the screws in the implant and abutment when torque is applied. An impactor have a variable mass and shape is ejected with a speed of 10 meters second on the crown of dental prosthesis. Finite element method. The mesh, the choice of finite element is one of the essential aspects of modeling. It is related to the calculation code, the type of analysis performed, and the capacity of the computer. This mesh can provide good results for one type of analysis and bad results for another type. The mesh of the compounds is linear tetrahedron elements with 4 nodes. The implant and the bone are meshed with increasingly larger elements as the distance from the interface increases, with the size of elements in contact with the core being defined by the element of the boundary mesh. The five results. The results. Scientists need to understand the mechanical behavior of dental prosthesis material in order to design more effective compounds to resist at impact. Using crown material that absorbs more energy from the impact and it transfers less energy to the following parts of the system: implant, abutment, and bones. The difference between the incident energy and the restored impact energy constitutes the energy absorbed by the dental prosthesis in the form of damage. This energy corresponds to the contact force and the impactor's displacement within the crown. Dental structure subjected to fast dynamic loading with both solid bodies, spherical and conical, were used as impactors. The crown was motionless and impacted by the impactor at a velocity along the horizontal direction, Z. The point of contact was selected as the target impact location. The figure 6 represents maximum volumetric stress in the cortical bone as a function of the mass of two kinds of impactor. The stress, the volumetric stress of the cortical of the impactor, the figure represents maximum volumetric stress in the cortical bone as function of the mass of two kinds of impactor. The level of volumetric stress of conical impactor is greater than that obtained by spherical impactor. The figure 7, the figure 7 represents maximum vomices stress in the cancellous bone as a function of the mass of two kinds of impact. 2 points of stress concentration, height stress, are usually found at the tip of circular hole of connecting cortical bone to implant, and implant tip connection with cancellous bone. Stress generated in cortical bone are more intense than those obtained in cancellous bone. On the other hand, it is noted that the maximum vomices stress generated by the physical impactor are lower than those the cortical impactor. Figure 8 depicted the maximum vomices stress in the implant as a function of the mass of both kinds of impactor. Whatever the impactor's shape, the numerical results obtained by the finite element method show that the value of the maximum vomices stress depend on the impactor's mass. It is noticed that the conical impactor leads to maximum vomices stress in dental implant, more significant than that caused by the spherical impactor. Figure 9 represents variation of equivalent stress in the cortical bone along circular path for different spherical impactors. It is noticed that stress transfer is performed from the implant to bone. The stress varies proportionally to the impactor mass. The conical impactor leads to an equivalent stress greater than that of the spherical impact. Figure 10 depicts variation of equivalent stress in the cortical bone along the circular path for different conical impactor mass. It is noticed that the curves, the vomices stress are evaluated in cortical bone along circular path. It is noticed that the curves shape of the equivalent stress are similar for different impactors mass, as shown in figure 10. And now figure 11. This figure represents variation of the equivalent stress in the cancellous bone along the bone interface for different spherical impactor. This figure show that the level of stress in the cancellous bone is less than of the compact bone. Figure 12. This figure represents variation of the equivalent stress in the cancellous bone along the bone implant interface for different conical impactor mass. Figure 13. This figure illustrates the variation of the equivalent stress in the implant along the bone implant interface for different spherical impactors mass. This figure illustrated the variation. It is noted that the curve of the equivalent stress exhibits fluctuations, stress peak and low volumetric stress corresponding respectively to the localized stresses at the top of the thread and at the bottom of the thread. The intensity of the equivalent stress increases the impactor's mass. In relation to the other compounds of the dental prosthesis, it is noted that whatever the mass and shape of the impactor, the weakest volumetric stress are generated in the cancellous bone. Figure 14. This figure represents the variation of the equivalent stress in the implant along the bone implant interface for different conical impactors mass. This stress increases proportionally to the mass of the impactor for both types of impactor. It is noted that the maximum stress is located at the cortical bone implant contact surface. Conclusion. This study investigated the biomechanical response of dental prosthesis after impact. Two typical shapes of impactor, also their masses, are highlighted to evaluate volumetric stress. The conical impactor leads to a greater equivalent stress than that of the spherical impactor. The stress distribution and level depend on the impactor's mass and different shapes of impactor. The curves are clear for different masses of the impactor. Indeed, the equivalent stress increases with increasing the impactor's mass, and the stresses were transferred from the implant to the surrounding cortical and cancellous bone. For big mass of the impactor, the stress may be critical since the mechanical properties of the implant material and the cortical and cancellous bone could not withstand stress magnitudes recorded in this analysis. It is recommended to use composite and above all acrylic resin crowns were more able to absorb shock from horizontal forces than crowns made of ceramic material. Thank you for your attention.
Thank you very much, dear Dr. Djebbar, for your presentation. Questions, please. You can write your questions in chat, for example. Okay, while some people are printing the questions, I would like also to ask something. So the first question is about just to establish the problem. So you have the part of the mandible with cortical bone and cancellous bone inside, yeah?
Yes.
And after that, you have such assembly of implants, crown, framework, abutment implant inserted in this geometry. And you have two types of bodies, of solid bodies with different shapes, which contact from velocity 10 meter
10
per
meter.
second. Yeah, 10 meter per second with this. Okay, and just evaluate. Okay, so what's the source of the problem? So do you work with medical staff and they told you to compute this kind of problems, or why you choose your problems? And okay.
Well, our problem is to protect to protect the crown, and the second problem is to predict the damage of crown. Excuse me. So the first is to protect and predict the distribution and the level of stress in the different parts of the prosthesis, of the dental prosthesis.
Okay. So, and also question in the chat that it correlates with my question. Why did you choose these two types of impactor?
The type of
impactor. You can see in the chat. Why did you choose these two types of impactor?
I choose two kinds of impactor: the spherical impactor and the cortical impactor. The purpose of this study is to compare between both impactors, to compare the level of voromisis stress between spherical and cortical impactor. As a result, the conical impactor leads to significant stress in different compounds of the dental prosthesis.
Okay, but theoretically, you're able to analyze any shape of impactor, so you can choose another shapes. You can, yeah.
Yes. I can choose another configuration of impactor.
Okay, so please, the question is in the chat from Professor Maslov. Please describe the dynamic statement of the problem, so the time of impact and so on. Can you tell something?
Is a lapse time the force, the load applied on the crown is applied during short time. One second.
So the time was 1 second.
One second.
1 second. So you simulated the contact during 1 second.
1 second, yes.
It's dynamical kind of problem.
Is a dynamic loading.
Yes, dynamical loading. And so how in Abacus did you solve this problem?
I resolved this problem with the software Abacus.
Yeah, we know about this. Please, please give us maybe some details. How can you solve these dynamical problems in Abacus? Do you need to write some additional subroutines or just choose a configuration in the software?
No, I don't need for subroutine. Just I used Abacus software Abacus.
Okay.
Explicit method.
Explicit solver. You used explicit. Okay.
Explicit method.
Okay. And do you plan to make some validation, for example, to make some experiments on?
I don't valid by experimental work, but we compare our work with other research.
Okay. Okay. But I think that it would be very interesting that you can take a mandible from the cadaver and try to simulate to mimic the situation which you are trying to compute, and to compare the displacements, for example, in your computational model and in the real model. So it would be really interesting comparison, maybe in future.
Reported to MIMC materials, and then cloud points which were extracted from MIMX in STT format were imported into SolidWorks, Dassault Systems Corporation, upon modeled resembling the premolar region of the identification mandible.
Okay. Okay. Thanks. Is there questions? You can also write in the chat or ask directly Dr. Djebbar. Okay. So if there is no questions, thank you very much for your presentation. So it would be really interesting. And I guess that this problem and this task is really interesting. And of course, maybe if you will do additional validation and experiments, it would be really interesting and enrich your work. So we want to wish you luck, and hope that we can see each other, for example. at a conference or something like that. So thank you for your presentation. And I will switch into Russian to tell some words for the audience. Okay?
Thanks, Mr. Alex. And I found that this suggestion are interesting.
Okay, thank you very much. So I will switch into Russian. Okay?
Okay.
Okay. Спасибо всем за участие в семинаре, за вопросы. Увидимся тогда на следующей неделе. Всем спасибо, всего доброго, до свидания.